right, so today we're going to look at equilateral and isosceles triangles that we have heard before, and we're going to explore a little more closely. So the first one is our isosceles triangle. That is our triangle with at least two sides congruent. So you can see my diagram here. Here are my two sides, which I'm referring to as the legs. They are congruent. And then at the bottom, you'll see I actually have two angles that are congruent. We call the base angles. And at the very top, that last angle is actually called our vertex angle. All right, so a little bit more about our isosceles triangle. So when we have two sides that are congruent, then the two angles opposite those sides are congruent. Now, what that means, so here is our two sides, and I kind of see them like arrows. So what that looks like is that's telling me that angle A is going to be congruent to angle B. Those two sides, I kind of turn them into arrows to let me know where those two base angles are going to be. So we're going to use that technique in our first example. It tells me in this triangle we have sides DE congruent to DF. So what angles are going to be congruent? So pause your screen real quick, figure out which two are going to be congruent, and then let's see. All right, so here I kind of turn this into, again, an arrow, so I know angle F is going to be congruent to angle E. And I can mark that off on my diagram. The reason for that would be a definition of isosceles. Those are my base angles. All right, example 2. So here we have our blank diagram. The very first thing is we're going to read the given information and mark up our problem. So it says if DE is congruent to CD and BC is congruent to AC, and the measure of angle CDE is 120 degrees, what is the measure of BAC? So that's a lot going on, so we're going to take it piece by piece. So DE is congruent. So DE is going to get one tick mark, and CD is going to get one tick mark. So I hope you can see right now, I already know I have an isosceles triangle in that top triangle. That is telling me BC is congruent to AC. All right, now we also have that tiny triangle at the bottom that's going to be isosceles. It also tells me that measure of CDE is 120. Where to put that? Now we're going to follow it out through our letters. So CDE, that means D is 120 degrees. All right, so now we have to actually fill in a little bit of information. So the first thing is I need to figure out some more angles. So remember in the beginning, I said that this is an isosceles triangle. So I know that these two angles are going to be congruent. I have enough information to figure out these two missing angles by using the triangle sum. So I know that a whole triangle is 180 degrees. So I can say 180 minus 120 is 60. That means between these two angles, we have 60 degrees. So I'm going to divide that by 2. That makes both of these angles 30 degrees. All right, we're not done yet. We're still moving through our picture. So now I need to move into the other triangle. Now remember, we're using all our skills and terms that we know about our triangle and angle relationships. So I can already see that this 30 here is vertical, so I can move it over right here. So since it is vertical, that's why it's congruent. Now, again, remember we said we had a small isosceles triangle here, so I know that these two angles are going to be congruent. So we're going to repeat the same process we did in the first triangle. So 180 minus 30, that is going to give me 150. That's 150 between these two angles. They're the same value, so I'm dividing by 2. And that makes it 75 degrees. Notice how I'm filling in all my information on the diagram as much as I possibly can. All right, so now going back to what it's asking, BAC. So BAC, they want angle A right there. So measure of angle BAC is 75 degrees. All right, let's go to the next page. All right, still looking at our isosceles triangle. Now we're just saying that we can have the converse of that theorem. Remember, converse means to switch or flip. So if we started saying we had two sides, now we're saying two angles. So here, if I know these two angles are congruent, that means the sides across from them need to be congruent. All right, so using that skill, let's look at the next example. It says angle A and B in this figure are congruent. What two sides are congruent because of it? All right, so pause your screen and let's see if we can match our sides. All right, so here I know that this is across from AC and A is across from BC. I just used two tick marks. It's okay if you used one or two. It doesn't really matter. So now I'm going to write out my statement. So I'm going to say that AC is congruent to BC. Those are my two sides. You want to make sure you're writing it as a congruency statement. They are congruent to each other. Remember, two letters to name a side. All right, so now example 4. So here we have triangles connected again, and we want to first think of the very first thing is, can I add more markings? So that's the first thing I'm always trying to think about. Can I add markings wherever I can? So let's start at the very first triangle. I'm going to highlight that triangle. All right, so this is incorporating our skills that we've learned so far in this video. So here we have two base angles here. So because I have those two angles, I can mark off two congruent sides. So I can mark off this side and this side. Notice I'm using two tick marks instead of one because we already have one pair. All right, going into the second triangle, I can see that I have two sides congruent, but I know I have two angles that are congruent because of it. It's an isosceles triangle. So this is pointing down into that corner, same over here. And that is all the markings I can add. So now I can answer the questions. It says, name all the congruent sides and congruent angles. So let's start with our angles. So I'm going to name angles with 3 letters. Remember, the letter that we want goes in the middle. So angle PLM, that's right here, is congruent to angle PML. That's angle M. All right, repeating that process for the other triangle. So we have angle MNL is congruent to, so that's angle NM right here. And then here I'm going to have MLN. So again, we sandwich in that letter that we want. All right, now congruent sides. Starting again with that green triangle, we have PM is congruent to PL, and then we have ML is congruent to MN. All right, so now we're going to see our equilateral triangle on the next page. I actually just moved that over, so don't worry about that. All right, so here we have our equilateral triangle. Notice in this picture, we have all the sides marked off. They are all equal. And then the angles all have curve markings. They are equiangular. That means that all angles are congruent. They're the same value, right? In each angle in an equilateral triangle, they all measure 60. I'm going to show you how it's 60. Remember, we had curve markings here. That means each one is the same value. For instance, I'm just putting X to show you the equation I can create. So a triangle, again, is always 180 degrees. So I can say 3x, x plus x plus x, equals 180 degrees. That means all the angles are the same value. When I divide both sides by 3, I get x equals 60. So that is every single equilateral triangle. All right, so using that skill, let's look at our diagram right here. So we have triangle PQR. They have a tick mark on each segment. It's one tick mark on each segment. What type of triangle do we have? So this triangle is an equilateral. We can tell that just based on the tick marks. So based on those tick marks, I could actually add the curve markings. And I can say that angle P equals 60. The measure of angle Q equals 60. and the measure of angle R equals 60. All right, so now what we're going to do, we're going to apply those skills and see how we can build connecting equilateral triangles and isosceles triangles in class. All right, so make sure you have these notes and make sure you ask any questions if you have, and I will talk to you guys in class.